Welcome back to the Fundamental Questions channel, second episode of the Human Story series.
It's great to be back.
I want to start today by doing something a little weird. I want you and our listener to just pause for a second and think about what is physically happening right now.
Okay.
I am forcing air out of my lungs. I'm vibrating these two little fleshy folds in my throat, and I'm, flapping my tongue and lips around to make these very specific rapid-fire noises.
Right.
And somehow, those noises are traveling into your ear, turning into electrical signals, and reconstructing a complex idea inside your brain.
When you break it down like that, it really does sound less like communication and more like, I don't know, a biological form of telepathy.
It does, but we do it so effortlessly, we forget how biologically strange it is. We're the only species that does this. So today, we are going on a deep dive into the origins of language.
And not just the what, but the how and the why.
Exactly. The mission here isn't about grammar or vocabulary. We want to unpack why we started doing this. Was it for survival, social bonding, or was it just a massive biological gamble that happened to pay off?
It was absolutely a gamble. And what's so fascinating about the stack of sources we have, and we're talking evolutionary biology, primate research, archaeology, neuroscience, is that it shows language didn't just pop into existence.
It wasn't a light bulb moment.
Not at all. It's a puzzle with pieces scattered across millions of years.
So let's start with that why. Because usually we think evolution is all about, man the hunter. We needed big brains to organize the hunt. But the research suggests the driving force might have been, well, a lot less heroic.
A lot more mundane in a way.
It suggests we started talking because we needed to gossip.
And that brings us to the social brain hypothesis. For a long time, the assumption was just what you said. Big brains are for solving ecological problems. How to use a tool, how to find food. But when researchers looked at the data across all primates, they found a different correlation. The size of the neocortex, the thinking part of the brain, it doesn't track with how hard it is to find food.
What does it track with?
It correlates almost perfectly with the size of the social group.
Wow. So you're saying our brain complexity reflects our friendship complexity.
Essentially, yes. Managing relationships is cognitively expensive. You have to remember who's friends with whom, who's an enemy, who owes you a favor. It's a constantly updating social database.
Which leads us straight to that famous metric, Dunbar's number.
Right, Robin Dunbar. His work suggests that for humans, based on our brain size, there's a kind of cognitive limit to our social group of about 150 people.
The clan, the village.
That's the number of people you can know well enough to actually trust. But that created a logistical nightmare.
Because in the primate world, you don't build trust by sending a text message.
You do it through physical grooming, picking lice, stroking fur. It's biochemical. It releases endorphins, builds trust. It's the glue of primate society.
But it's a one-on-one activity.
Exactly. It's incredibly time-consuming. For a chimp in a group of 50, you can spend maybe 20% of your day grooming your allies. But for an early human in a group of 150, the math just, it falls apart.
I saw the numbers on this. To keep a group of 150 happy, you'd be picking lice for something like 40, maybe 50% of your waking hours.
You'd starve. You'd have no time for anything else. You hit a time budget wall.
So we needed a more efficient way to groom.
A way to groom multiple people at once. And that, the theory goes, is language. It's vocal grooming.
I love that phrase, vocal grooming. So me telling a story around a campfire to 3 friends is like I'm picking lice off all 3 of them at the same time.
It is. It's an efficiency hack for the social brain. And it allows for something physical grooming can't do at all, gossip, which we think of as this negative thing, but in an evolutionary sense, it's a survival tool. It's how you monitor reputations.
Because in a group of 150, I can't see what everyone is doing. I need to know if that guy over there is a reliable partner or if he's a cheater who steals tools.
Exactly. Language lets you know who to trust without direct interaction. It lets cooperation scale up. So we started talking to save time and to avoid getting stabbed in the back.
We outsourced the lice picking to our vocal cords. That's amazing. But okay, that's the why. What about the how? Because you can't just decide to speak. And it seems like there's a big debate here. The hand people versus the mouth people.
There is, yes. the gestural theory versus the vocal theory.
Let's start with the gestural theory, the idea that we waved before we spoke.
The evidence for this is actually quite strong if you look at our ape cousins. They have fantastic voluntary control over their hands. They can point, they can beg, they can even learn sign language.
With their voices.
Their vocalizations are largely automatic. They're tied to an emotional state, like a reflex. A chimp sees a snake, it lets out an alarm call. It can't really control it.
They can't just decide to make a snake alarm call for fun.
Precisely. Whereas you can say the word snake right now without feeling any fear at all. That voluntary control is the key.
And there's a brain connection. Yeah.
There is. An area in a monkey's brain called F5, which controlled hand and mouth actions, is the evolutionary cousin to Broca's area in our brain.
Which is our speech production center.
So the theory is that the neural wiring for language was basically built on top of the wiring for manual gestures. We mimed first, and that system it got recruited for speech.
Which is why I'm waving my hands around right now, even though you're not in the room. It's like a backup system.
That's a great way to think of it. But there's a strong counter-argument. And this is where the vocal theory comes in, because human babies tell a very different story.
The protophones. The little squeals and growls.
Yes. Human infants, long before they can talk, they make all these sound squeals, raspberries, vowel-like noises. And crucially, they do it when they're calm and content.
They're just playing. Exploring the instrument.
Yeah. They are exploring their vocal range, completely disconnected from emotion. And that's something other primates just don't do. A baby chimp doesn't sit around playfully practicing its alarm calls.
So that playful exploration, that might be the bridge. It's practice and maybe a fitness signal to the parents. Hey, I'm healthy, invest in me.
That's the idea. It provides the raw material, the ability to decouple sound from emotion that language needed. But you have to combine that with what's called the interaction engine.
I found this concept so powerful. The idea that the will to communicate came before the words.
Yes. Things like joint attention, the ability for you and I to both look at a cup on the table and know that we're both looking at it and thinking about it together.
A communication triangle. Me, you, and the thing.
And we think that engine turn-taking, mutual gaze, the desire to share attention was in place with Homo erectus, maybe even earlier. We were a species dying to communicate, just waiting for the hardware to catch up.
Okay, let's talk about that hardware, the anatomy. Because this is the part that, it made me physically touch my own throat. Our ability to speak comes at a potentially lethal price.
It's a huge trade-off. To make the sounds we do, our larynx, our voice box, had to drop much lower in the throat compared to other primates.
Right. For most mammals, the larynx is high up. It locks into the nose so they can drink and breathe at the same time.
We can't do that. We choke.
Because our food pipe and our air pipe cross over. It's a design flaw.
It's a flaw that creates a massive advantage. Dropping the larynx created a resonating chamber, the pharynx, that lets us shape sound into all the distinct vowels and consonants we use. But yes, it means we can choke to death on our food.
So evolution basically decided that the ability to talk was worth the risk of dying at dinner.
The benefit of complex speech must have been absolutely overwhelming.
Now, for ages, we thought this was a Homo sapiens exclusive. But that whole timeline has been blown up, hasn't it?
Completely. The idea of a creative explosion 40,000 years ago is it's out the window. And the hyoid bone is a key piece of evidence.
That little horseshoe-shaped bone that supports the tongue.
Yes. We found one in Kabara Cave from a Neanderthal, and it looks almost identical to yours or mine. Anatomically, they could speak.
So no more Neanderthals just grunting.
No. And then there's the genetics. We have to talk about FOXP2.
The language gene.
Well, it's more of a regulator gene for fine motor control, but mutations in it cause severe speech problems. You can't coordinate the complex movements for speech.
And Neanderthals had our version of it.
They did. We share specific mutations in FOXP2 with Neanderthals that chimps don't have, which means the genetic groundwork for speech was likely laid in our common ancestor maybe 500,000 years ago.
That's a game changer. It means language wasn't a sudden spark in us. It was a long, slow burn across the entire genus Homo.
Exactly. And that brings us to maybe the most beautiful evidence of all, the link between language and art. The symbolic Rubicon.
I love this. We can't hear our ancestors, but maybe we can see their language.
That's the logic. Language is symbolic. The word lion is not a lion. It's a sound that represents the idea of one. Art is the same cognitive leap. To draw a bison on a cave wall, you have to be able to think about something that isn't there.
That concept of displacement.
Yes. And we see evidence for this so much earlier than we thought. There's an engraved shell from Java made by Homo erectus,
500,000 years ago.
with a deliberate zigzag pattern carved into it. That's abstract, that's symbolic thought.
And the Neanderthals were painting caves in Spain more than 64,000 years ago.
Long before modern humans got to Europe. So the old story of us showing up and bringing art and culture with us is just wrong. They were already doing it.
So if they had the hyoid bone and the FOXP2 gene and they were thinking symbolically.
And they were almost certainly talking. They had a language-ready brain. The foundation for language is ancient. We might have added more complexity, but we didn't invent it from scratch.
But there's one last piece. You can have the hardware and the brain, but you need the right temperament. Why even bother sharing information?
This is the critical question. Language is cooperative. If I tell you there's a lion behind that rock, I'm giving you life-saving information for free. You have to trust me.
And if we're a species of backstabbers, language is just a better way to lie. It would never work.
Precisely. We needed a baseline of what's called prosociality. And the best way to understand this is to compare chimps and bonobos.
Our closest relatives.
Chimps are geniuses with tools and physical problems, but they're also highly competitive. Bonobos, on the other hand, are much more tolerant, better at sharing, better at social cooperation.
So we needed the problem solving of a chimp, but the temperament of a bonobo.
That's a perfect way to put it. We needed a reason to trust each other. And that pressure might have come from things like scavenging large carcasses where you have to work together, or cooperative breeding.
It takes a village.
It takes a village, and that village life physically reshaped our brains to be more cooperative and communicative. It's the soil language grew in.
So if we pull this all together, it's this incredible convergence. Big social groups forced us to switch from physical to vocal grooming. We developed the risky anatomy to do it. We started playing with sound as babies. And we developed the trust and the symbolic thought needed to make it all worthwhile.
It's a feedback loop of biology, sociology, and ecology, all reinforcing each other over hundreds of thousands of years.
It makes you think. The next time I'm just gossiping with a friend, I'm actually engaging in a sophisticated, ancient primate bonding ritual.
That is exactly what you are doing.
But this is where I want to leave things. We talked about Dunbar's number, that cognitive limit of about 150 people that our social brain was built for.
Yes, designed for face-to-face interaction in a small community.
But we don't live there anymore. We live in a world where I can communicate with millions of people instantly.
And this is the provocative question. That interaction engine we talked about, the turn-taking, the trust, the shared context, it evolved for proximity. We have now plugged that ancient biological machinery into a global digital network.
We're trying to vocal groom the entire planet at once.
And you can see the strain. When you remove the physical context and scale the numbers past 150, does that mechanism start to break down? Are we pushing the social brain way past its design specs?
It's why social media can feel so overwhelming. We're trying to track the reputations of thousands of people. When our brains are wired for a village, we're hyper-stimulating the gossip function.
It's very possible. We're running Stone Age social software on space-age communication hardware. A system designed to track who owes you a favor in the clan is now trying to process the entire planet.
That is a slightly terrifying but fascinating thought to end on. We're ancient machines trying to navigate a world we weren't built for, using the very tool that got us here.
And language is that bridge. We're still just figuring out how to use it at this new scale without it short-circuiting.
Well, on that note, I think that's a perfect place to wrap this deep dive. It really does change how you think about just opening your mouth and saying hello.
It certainly does.
Thank you, everyone, for listening to this deep dive. If you enjoyed unpacking the origins of us, please make sure to subscribe to the Fundamental Questions channel. We have so many more episodes coming up in the Human Story series.
Indeed. Keep asking questions.
See you next time.